So algebra and expressions. Basically, what is x? So most people are not too familiar with this fact, but x can be representing an unknown value, but it can also represent a variable. And those are two different things. So an unknown value is when the x represents some number that's unknown. So for example here, x plus 3 equals 2. Well, this x is a specific number. In fact, this x can only be one number, and that number is -1. Otherwise, that equation is not true. So this is an unknown value. Okay, so these are ones that we can actually solve for. X can also be a variable. So x, in this situation, y equals x minus 3. Well, x can take on many different values. So x could be 1, and that would make y equal to -2. X could be 0, and then y could be -3. X can take on many values, okay, so it's called a variable. So we want to start distinguishing between when we're dealing with an unknown and a variable. So an unknown is something we can solve the number for. A variable is when the x can take on many different values. Okay, in this case, when x changes, y has to change with it. So x and y are actually connected, or they're related. So if we take a look at these things here, are the x's in these variables or unknowns? So if I take a look at the first one here, 2x minus 4 equals 10. Are there lots of different x's that we can substitute in there? Or is it a variable? Or sorry, is it an unknown? So variable means we can substitute lots of different x's. An unknown means there's a specific x for that one x there. So in this case, this is an unknown. Okay, this is an unknown. And unknowns are ones that we can actually often figure out. So for B, x plus y equals 10. Can x take on many different variables? Can x take on the value of 1? Can it take on the value of 2, 3, 4, etc.? And the answer to that is yes, it can. It can take on different values, so it is a variable. Okay, so it is a variable value. So with C, we have 5x plus 1. Now it's not actually equaling anything, so can x take on many different values? And again, the answer would be yes. So this is, again, a variable. Okay, it can take on many different values. We can evaluate this expression for different values of x. Okay, x could be 0, x could be 1, x could be 2. So this is important to start kind of distinguishing the fact that when we see x in algebra, x can sometimes be an unknown, sometimes it can be a variable. When we see unknowns, we're going to actually end up solving for those unknowns when we can. So we also want to distinguish between expressions, equations, and relations. Okay, those are three different things when we see algebraic terms. So an expression is one like this. An expression, in this case, x is a variable. So in expressions, x's are variables. And expressions can be characterized by the fact that there's no equals here. Okay, so I'm just going to put in brackets. There's no equals. Okay, so that's a way we can kind of recognize when something is just an expression. It doesn't actually equal anything. It's just some kind of calculation, and we're not making it balance anything. An equation is when we can actually solve for x. Okay, we can find the number for x. So this is an unknown. Okay, this x is an unknown, and we can actually solve for that unknown. Okay, so in this case, I'm just going to put brackets here. X is an unknown. Okay, and the last one is a relationship. A relationship is when we have two variables and they're connected in an equation. Okay, if I have two variables and they're not connected in an equation, so for example, I could do 2x plus y divided by 2, okay, and this would be an expression. Okay, maybe I'll do that in red to show that it is an expression. It has two variables, but it's still an expression. So 2x plus y having two variables is still an expression because it's not equal to anything. But here we have x minus y. We have two variables, and they're connected with an equation. And this is what we call a relation or relationship. And relations are characterized by the fact that as x changes, y changes in a pattern. And that pattern can be shown in a graph on an xy plane. So this is an important characteristic of relations, and this is what we're going to end up getting into when we get into grade 10, 11, 12. We start dealing with lots of relationships because we want to know how something changes with another variable. And we want to see what it looks like. Okay? And we can see what it looks like in an xy graph. So these ones here, I want you to state whether these are expressions, equations, or relations. So for A, there's 1x, but there is no equal sign here. So this is an expression. Okay, so that expressions are most easily characterized by the fact that there is no equals. In B, there is an equals, but there's two variables. Okay, so expressions can have two variables, but expressions can't have an equals in there like this. So this is a relationship or a relation. Here, this is an x in an equation, and this x can take on a specific value. So this is an equation. Oops. So this represents an equation. Okay. For D, this is connecting an x to a y. Okay, and as x changes, the y changes. So this is definitely a variable because it can change. But because it's changing with respect to x, as x changes, y changes with it. They are connected to each other. They are related to each other. So this is what we would call a relationship. And we can have a relationship in an equation, in a table like this, or in a graph, which we kind of described before here. Okay? So what I would like you to do is I would like you to check this video out. Okay, the video is what is algebra. You can go to the link on your handout. Okay, and you need to answer these questions on your handout. Okay, and then you can come back to the video. So at this point, you're going to stop the video. Okay, you're going to go to the video link, the YouTube video for what is algebra. Okay, it is a video. I think it's a math antics video, and there are 3 questions that you need to be able to answer from the video. Okay, so once you've answered those 3 questions, you can come back and we'll continue with the rest of the notes.